What's up guys, this is Massey. Welcome to another video. In this video I want to show you how to find out a cofactor in matrices. First example I have here is matrix A is 1, 3, 2, negative 1, 0, 4, 7, 5, negative 2. And we need to find out the cofactor of the second column. So we need to say the first term on the second column is 3 and the position is 1 and 2. It's on the first row, second column. So position is 1 and 2. And then we need to basically remove this row and column and then find out the determinant of the rest of it. But before that we need to say negative 1 to the power of the summation of the position. So we have 1 plus 2 times determinant of negative 1, 4, 7 and negative 2. Basically the remaining elements. So that's basically negative 2. So negative 1 to the power of 3 is negative 1. And here we have negative 1 times negative 2. 2 minus 7 times 4 is going to be 28. So it's going to be positive 26. Next one is 0. Position is 2 and 2, the second row and second column. So we have negative 1 to the power of 2 plus 2 times determinant of the elimination of this row and column is going to be 1, 2, 7 and negative 2. 1, 2, 7 and negative 2. That's going to be 1 times 2, 1 times negative 2 minus 2 times 7, which is going to be negative 2 minus 14 is going to be negative 16. Then next one is going to be element number 5. Position is 3 and 2, which is this one. Third row and second column, so it's going to be negative 1 to the power of 3 plus 2. Determinant of elimination of this column and this row is going to be 1, 2, negative 1 and 4. Which will be negative 1 times 4, 4, minus 2 times negative 1, which is plus 2. That's going to be negative 6. So basically these are the cofactors of the second column. Next example, it says find out the cofactor of 6, 7, 8 when we are dealing with a 4 by 4 matrix. So let's start from 6. Cofactor 6. The position is 4 and 4. So if we eliminate this column and this row, we're going to get a 3 by 3 matrix. So that's going to be negative 1 to the power of 4 plus 4, which is going to be positive 1, times the determinant of this. So I'm going to write 1, 3, 2, 0, 2, 4, 4, 1, 3. Which will be 1 times 2 times 3, 6 minus 4, plus negative 3 times 0 times 3, 0 minus 16, 2 times 0 times 1, 0 minus 8. It is going to be 2 plus 48 minus 16. So that's going to be 32 plus 2 is going to be 34. That's going to be the cofactor of 6. Now let's find out the cofactor of 7. We need to find out the position first. Position has one S. That's 7 is going to be row 2, column 4. So we have 2 by 4. Negative 1 to the power of 2 plus 4. Determinant of 1, 3, 2, 4, 1, 3, 8, 5, negative 2. So that's gonna be 1 times, when you remove this one, it's gonna be 1 times negative 2, minus 15. Negative 3 times, 4 times negative 2, negative 8, minus 24. 2 times, 4 times 5, 20, minus 8. That's going to be minus 17. Here you have negative 32 times negative 3 is going to be positive 96. And 20 minus 8 is going to be 12 times 2 is going to be 24. So when you add them, that's going to be 103. That's going to be the cofactor of 7. Now we need to find out the cofactor of 8. Cofactor 8. 8 is position 4 and 1, the 4th row and 1st column. So it's going to be negative 1 to the power of 4 plus 1. Determinant of 3, 2, negative 1, 2, 4, 7, 1, 3, 9. So it's basically this matrix. That's going to be 3 times 36 minus 21 minus 2 times 18 minus 7 plus negative 1 times 6 minus 4. That's going to make it as 3 times 15 negative 2 times 11 minus 2. So it's going to be 45 minus 22 minus 2, which is going to be 21. Now I want to show you how to find out the cofactors of all the elements. Here we have them 3 by 3 matrix, and we want to find out all the cofactors. I'm going to start with A11 for the first one. That's going to be negative 1 to the power of 1 plus 1 times determinant of the remaining, which is going to be 1, negative 1, 3, and 4. That's going to be, that's positive 4 plus 3, 7. A12 is going to be negative 1 to the power of 1 plus 2. It's going to be 0, negative 1, negative 2, 4. 0, negative 1, negative 2, 4. That's going to be 0 times 4, 0, minus negative 2 times negative 1 is positive 2, is going to be negative 2. A13 is going to be negative 1 to the power of 1 plus 3. That's going to be 0, 1, negative 2, and 3, which is going to be positive 2. Next one is going to be A21, negative 1 to the power of 2 plus 1. That will be negative 1, 3, 3, and 4, which will be negative 1 times negative 1 times 4, negative 4, minus 9 is going to be negative 13 times negative 1 is going to be positive 13. Then you have A22, negative 1 to the power of 2 plus 2. You remove that one, 2 and 2. is going to be 2, 3, negative 2, 4. That will be 2 times 4 minus negative 2 times 3. That's going to be 8 plus 6, it's 14. Next one, a 2, 3, negative 1 to the power of 2 plus 3, 2, negative 1, negative 2, and 3, which is going to be negative 1, 6 minus 2, which is 4, that's going to be negative 4. We have a 3, 1, negative 1 to the power of 3 plus 1. That's going to be the third row and one column. First column here is going to be negative 2. We remove that and we have negative 1, 3, and 1, and negative 1. That's going to be negative 1 times 1 minus 3, which is going to be positive 2. a 3, 2 is going to be negative 1 to the power of 3 plus 2. You have 2, 3, 0, and negative 1. That will be negative 2 times negative 1 is going to be positive 2. And finally, a 3, 3 is going to be negative 1 to the power of 3 plus 3. That's going to be 2, negative 1, 0, and 1. That's going to be 2. So basically that's how we find out the cofactors of the matrices. I hope you enjoyed this video. Please leave me a comment if you have any question. Thank you for watching and have a great day.